So I have different choices for what should be the first original video, let's say, for this channel. I mean, the inaugural video being the presentation, going through that makes perfect sense. But the one outside of the presentation, what should that be? And really, only one would make sense. Would make the most sense. That is to go through dark space, because I do think that's probably one of my strongest topics from the presentation. So, going to be getting into that, but quickly should explain that this is the Ring Nebula. It's an image from the Hubble Space Telescope, and it actually will be helpful for this video, believe it or not. But anyway, so if you've seen the presentation video, thank you for watching through it. That's a long one. This one will hopefully be shorter, but I ramble. My apology. It also means I am not doing a script for yeah, sorry. Let's just get to it. So, dark space, in order to understand that, I need to talk about interstellar space, and that I hate that term. I also don't care much for what the actual measurement is associated with it, but I hate the term. Because let me ask you this question. What is it? What is interstellar space? Now, if you break down the word, you get the space between stars. Okay, good. Good. That's a good place to start. But we got this image here, right? Let's imagine this is a map, because we got a few stars in it. Where's the line on this between stellar space and interstellar space? You probably don't know. Because there's nothing from the term interstellar space that tells you where that line is. Alright? So, what is the actual definition of interstellar space? I have it here. I'll tell you. It's the space beyond the heliopause of a star. Or technically all stars, but space beyond the heliopause. You break down interstellar space between stars. You break down heliopause, where stars are stars are paused. By the way, I have speech impediment. Don't worry, it's not it's annoying. It's a frustration to me, but it's whatever. But yeah, heliopause. That's Let me give you another definition. The technical terminology or characteristic idiom of a special activity or group, obscure and often pretentious language marked by circumlocutions and long words, confused, unintelligible language. That's the Merriam-Webster definitions for jargon. Cambridge. Special words and phrases that are used by particular groups of people, especially in their work. Oxford Learner's definition. I didn't realize that was a thing until I was looking up. Words or expressions that are used by a particular profession or group of people and are difficult for others to understand. And the American Heritage definition, which is what I got when I just did basics. Put the word in jargon. What's the definition? The specialized language of a trade, profession, or similar group, especially when viewed as difficult to understand by outsiders. Also nonsensical or incoherent language. Jargon. That's what interstellar space is as a term, and that's what heliopause is as well. To be fair, though, I think heliopause, you get a little bit more of a pass, because I doubt many people are really going to be talking about that. But interstellar space, there's a lot. Like, I got my movie collection all right here. There's a lot there that I could just grab, and it's like, it happens in interstellar space. I can grab 2 books of mine that I wrote that are set in interstellar space. And that's why I don't like the term interstellar space, because I wrote those books. Oh, man. So I came up with a different term. But let's get back to what interstellar space is. What is this heliopause thing? And hopefully I will remember and do a good job putting it in this place. A graphic over here that I made to try to show what the heliopause is. And I'm looking at the graphic. I don't have it in the video. I'll be doing that in editing. This is all going to be so much fun. But we have a star on one side, and we have some rays coming out of it that I've colored an orange. This is to represent the solar wind. A star such as the sun is constantly expelling charged particles at high speed, high energy as well, relatively low density. There's a reason why this is relevant. But yeah, it's constantly pouring those out. On the other side, so the star will be here, but further over. You'll see another set of lines. These are blue. That's because there is the interstellar medium. Basically, there's a lot of mass that's just sitting out there, not connected to any star, not part of any solar system. And that again, a lot of it is charged particles. But they're of higher density than the solar wind, which is why the dots in the graphic, they're closer together for that. They're also colder, which is why I have them marked blue here, because generally speaking, we do associate blue with being cooler, even though a blue star is a lot hotter than a red star. Anyway. And also, I made it yellow, but the sun is a white star. It's not yellow. It's looks yellow because of dust in the air. Anyhow, as the graphic tries to portray, when you've got the solar wind going this way and then the interstellar medium going this way, they collide. And where they collide, the pressures of the two kind of balance out. And this causes them to apparently pause, because they're balanced. That's what the heliopause is. It is this boundary yet formed by the solar wind and the interstellar medium. Now, this again leads to some problems, which is why I don't really like this as the definition for interstellar space, is why I choose not to use it in my stories. I use dark space and what its definition. This is kind of variable, and as I'm trying to show there, that technically the heliopause does have a width to it. It's like there would be a space where the balance changes. And it's also, and this is something dark space would also suffer from, or at least can, the position of the heliopause changes. The sun's activity changes on a 22-year cycle with highs and lows at 11 years. So that means then that the solar wind changes. So the heliopause and the heliosheath, the full thing that we're in, that the heliopause is the edge of that. It goes out and comes in. So apparently stellar space, the counterpart to interstellar space, varies. Lovely. Also, we're moving through the interstellar medium, which means that in one direction, we're ramming into the interstellar medium, and in the other direction, it's kind of trailing behind us. So the heliopause is not a sphere. It's going to be stretched, or at least it can be. Apparently there are some observations that it's more spherical than you may think, but it still is not exactly ideal because it can change in shape by the activity of the star. And its shape is not necessarily uniform either. It might be. Maybe it is. Maybe it is. That'd be wonderful. Because if you're talking about navigating a ship, we're not talking about like tides altering where the coastline is. We're not talking about something necessarily that regular. We're talking about major shifts potentially, and it is also it's a boundary that has a distance to it. So what is the actual start and stop of the of interstellar space? Where is the line? Is it on the inside? Is it on the outside? Is it in the middle? And now I have my notes. I don't have a script, but I do have notes. I just want to check. Was there anything else I wanted to? Oh yes, of course. Why am I using this specific Hubble image? There's another issue with interstellar space. It's defined by the solar wind, right? The heliopause, as I just explained. It's a solar wind. This is a nebula. What's at the center of this nebula? A white dwarf. A white dwarf is the dying core of a star. Okay? Like all the mass we see here, what happened is that's actually the bulk of the gases and dust and such of the star that was there. And it has now come off of the white dwarf and is spreading out. Come off of the core of the star and spreading out. And so you're left with that core there that's just it's basically a big hunk of carbon that's very, very hot. So it's still glowing and will continue to glow for billions of years as it cools off. And by the way, this will happen to the sun even in actually about 4 billion years, I think is the estimate. Anyway. A white dwarf, though, is technically dead. It's a dead object. It's just sitting there radiating heat, but not particles. So a white dwarf has no solar wind, which means its edge is right there to, like the surface of it is also the boundary to interstellar space. This is a little bit of a problem because we have actually found white dwarfs with planets orbiting them. So these planets though orbiting a star, a kind of star, are in interstellar space. Like, they could even have a stable orbit, but they're in interstellar space. I don't like this. I really don't. This seems like a lousy definition. Because you do have a class, a type of star. Yes, it's a dead star, but it still is a type of star that is in interstellar space. So you can have planets orbiting it. You can have a solar system with the planets are in interstellar space. How does this make any sense? So this is why I do prefer dark space. And hang on, I just want to check. Did I have anything else here? Oh yeah, there's also that. How do you measure the distance within interstellar space? How far is the border? Like, how do you know? I'm standing here. How do I know where the edge is? Or if I'm outside, if I'm in interstellar space looking in, how do I know where the edge is? You need to do particle detectors, but it's not like you can watch particles at a distance away. Light year away. You don't know where that is. You have to be there and measure the particles. So yeah, and why are we using such advanced technology? This is why I like my definition, my term, which is dark space. Which, if you look at the presentation, I think I do a better job setting it up. So if I ask you, what do you think dark space means? You can guess it. I'm just going to tell you, and I have my own graphic here, that the 2 white lines that I was using before for the edges of the heliopause, same lines here, I just changed the background. Dark space is just where it's dark, essentially. It is where there is no dominant source of starlight. Now, technically, there doesn't need to be a line, because the star you're closest to, its light would still be dominant, but at some point it just decays down where it's like, yeah, we can't noticeably tell this apart from the star that's hundreds of light years away that's just shining. And that's, I think a more useful definition. It's a lot easier to measure. You need a light sensor like that. That's a light sensor. And lenses, a telescope, which again, like that, because I'm using my Nikon with a lens on there. It's not this thing on my laptop that just has a piece of plastic over. It's like the actual optics. It's like that. That's all. I could use, in theory, you could use a Nikon camera. You could use a Canon as well. I mean, it's like, whatever. To measure your position relative to a star in that way and know, okay, am I in dark space or not? So it's a lot easier. I think that's also a lot easier to explain to people. That's why I came up with it for my books, is how do I explain this to people? That's a lot easier. It's where there's no dominant source of starlight. Much simpler than explaining that it's beyond the heliopause of a star and then explain what the heliopause. I don't like jargon. Technically, dark space is jargon as well, because it is specialized language. It's specialized in that I use it and my 2 books use it, and that's it. Let's change it. So just looking back at my notes here, but yeah, it's, well, technically it's jargon because it is used by so few. At the same time, though, its meaning is suggested by the name. It's the space where it's dark. And if you just associate it with, okay, we're measuring something concerning stars, stellar space versus interstellar, then okay, it's dark of starlight as opposed to just any other color of light, any other source of light. As I already said, it can be measured with a basic light sensor and telescope, which we already have around us. And it's also, anyone can do that. I'm saying, I don't have a particle detector, and I don't know if I got my hands on one, if I could properly use it and maintain it. I got my camera. I know how to use it and maintain it. It also is applicable to all light-emitting objects, including white dwarfs. Technically, also neutron stars. Pulsars would get weird, though, because those are they're neutron stars that only release light at their poles because the magnetic fields are very powerful. So technically that would be wonky, because in certain areas you would not get much light, but in other areas you would definitely get a lot of light, and at very high frequency as well. You don't want to get hit by them. But it is also, if you had any matter accreting around it, though, that may be glowing, that may give it away. And that would also apply for a black hole, where, yes, the black hole obviously is emitting light, but there might be material around it that illuminates. But it is also, I mean, a black hole, I think that's fair to just say, yeah, those are all in interstellar space. Not sure Neutron stars, again, we actually have found some that have planets, so it does complicate things. But at least it is, again, it's like there might be other sources of light directly attached to it. So maybe, but I'll grant, with those extreme objects, it gets a little wonky. Now, there are also some issues with dark space. I mentioned it is technically still jargon because very few people know. Like, if you talk to somebody who knows everything about astronomy, you start talking about dark space, they're not going to know what you're talking about. Unless somehow they see this. And I doubt. Technically, gas and dust can obscure it. I mean, look at the picture. That way. It is blocking some of the things we can see behind it. So it would attenuate your ability to figure out dark space. Yeah, I mean, that's not necessarily ideal. Another is technically there's a lot of different kinds of light. I mean, we associate everything with visible light because we see it. But would you maybe want to make the measurement in infrared light, which would actually be valid for the fact that infrared light can actually get through a lot of that gas and dust, so you potentially get a clearer signal. But you may also have the issue of there are some objects that will give off infrared light, but aren't necessarily stars, so that may throw some things off. What are ultraviolet? Well, you're getting into higher energy sensors. That might be not ideal. Microwaves and radio waves, again, there's a lot of things that can produce those. That maybe you don't want to use that. So you'd end up needing to do one of those whole, okay, we're measuring the brightness of the light, the amount of light emitted at this frequency. And we're collecting the number of photons from that frequency for this length of time, and just so it'll still get kind of very specialized, but it still is, you're working with a camera. I think a lot of people are going to find that a lot easier. And as I said, I think it's also just an easier term to explain, because I write a book. I'm not, here, you know what, I'm going to pause the video. I'll be right back. Alright. This is my book. See its size, 6x9, that thick. Here's one of my physics textbooks. It is much larger and much thicker. Okay? Don't get me wrong, I like the book. I really do. But it's just one of those, I have to tell a story and also explain the setting, how we're doing things in there and all that, in something much smaller and something much easier to read and enjoy for anyone. Whereas this, no offense, but this is not necessarily what a layperson wants to read. I mean, yes, a lot of lay people, they take physics, and they go through sections of this. But, yeah. This is not for everyone to read. I wrote this for as many people to be able to read as possible. So, yeah. Dark space makes sense. Interstellar space makes sense. Interstellar space doesn't make so much sense. Dark space? Maybe it could make sense. Don't know. Alright. But that's kind of my point, though, and why a lot of this is just, I don't like jargon. I don't like jargon. But it's nature of the beast for various things. Do what you can, though. That's part of the beauty of writing science fiction, or writing anything. You can just start doing what it is you want to do. Just try to make sure it's reasonable, and you can explain. If you can do that, you'll be fine. Can't, well, then maybe fall back to interstellar space. Fall back to the jargon that's already. Alright. See you next time.